Text Mining in R with Supreme Court Opinions, Part 4. Look, guys, I know that this is really long, okay? But what I'm trying to do here is be really thorough, and I'm trying to make this really accessible, okay? You guys can all go out to the internet and you can Google text mining R tidytext, and you can find 100 little one-page vignettes that show you how to do this stuff, right? But in order for those one-pagers to be accessible, you have to have a certain level of R competency. So those one-pagers are great, but a lot of them are only really accessible to people who know enough R to get something out of those one-pagers. And because you can Google text mining R tidytext and get 100 different illustrations to walk through, I don't want to be repetitive. I want to do something different. So I'm trying to do this as a little deeper dive, and I'm trying to be really thorough in talking through what each piece of code is doing. And I know that that can seem probably boring. This is going to end up being like 2 hours of video, but the reason I'm trying to do it like that is not because I think that I've developed this amazing algorithm and this great code to mine these Supreme Court opinions. It's because I want this to be accessible, first of all, to people as they're learning R, and I want you guys to be able to see what the logic is behind each part and each piece of code. I fully expect that by the end of the workshop, a lot of you guys will be able to go to the R Markdown in the GitHub directory for this particular illustration, and you'll probably be able to take a half an hour and rewrite the whole thing in a way that's much better than what I've put together. But I've put together something that works, and I'm trying to be really thorough in explaining how it works, so that you can kind of learn some R functionalities along with some text mining functionalities. Well, mercifully, I think we're ready to move on to the next step. And so the next step in this particular analysis is to parse out the data. So in the last step, in this get markers step, we marked up the data, we marked up the text, that is, and found the location of some text that I was interested in. In this step, I'm actually going to take that text and I'm going to parse it out into kind of a usable format. And to be a little bit more specific, right, the thing that we're going to do, the thing that I'm going to do with this text is to tokenize it. And tokenizing text is an expression that's used by folks in the text mining field when they want to split text strings into meaningful elements. And usually it's words. I tend to think of it as words, but I think people who do this a lot and people who are much better at it than I am would prefer to use a more general term like tokenizing, because there are lots of things that are not words that are still important elements of language that one might want to retain if they were doing a text-based analysis. I'm not going to try to comment on what those are because I probably would not do it justice. In this particular example, we're going to be dealing with splitting long text strings into words. So let's get started with that. In this get markers step, we produced a data frame. The data frame had information on the starting and ending pages of, for example, the majority opinion for this particular case. And to start with in this parsing step, I'm going to go ahead and make a Neil Gorsuch data frame that includes the text in doc, but only pages 4 to 45. So this is going to be the text, and so this is the text here for this majority opinion for this particular PDF that we have in the workspace. And the way that we're going to parse this out is actually pretty simple. I'm going to use, I have a step in here where I had removed the \n line break characters because I wasn't sure how those were being treated, but upon further testing of this unnest tokens method from the tidytext package, I found out that this unnest tokens method deals quite effectively with these \n's, meaning that it can identify the words even when the words are combined with these line break characters. So it's in here, it's in the file. It's not actually a necessary step at this point. Let me walk through what this unnest tokens method does. So unnest tokens is a function that's just going to break up a longer text string into words. Okay, so if I have and unnest tokens is a method from the tidytext package, and tidytext package prefers working with data frames. And so if I have some text in a data frame, just an example data frame like this, then unnest tokens. Words means that when I tokenize this text, I want it to break it up into words, and then text is the name of the field within the data frame that contains the text that I want to tokenize. And we go from what was a data frame with one row containing 3 words in a single text string to a data frame with one row for each word contained in that text string. And so using this method, just going back here, we have Neil Gorsuch df. Let me remind myself how that was organized. So that is not yet a data frame, so let's coerce that to a data frame where the value is the text that is in that large character vector. Okay, and then reassign that to the tokenized version, unnest tokens word text. It's because I did not give it the right name of the data frame. ng.df. And now if I look at the first few rows of that tokenized data frame, it's taken all the text from that majority opinion and it's organized it into rows. Each word or each token is now a row in this resulting data frame. And one more thing I want to point out, and then we are done with the single case example, is that after we use this unnest tokens method to split the text into this data frame, we get labeled rows. Now those are not terribly important to me for this particular application, but they might be important to you guys. So I wanted to just point out that we have 1, 1.1, 1.2, 1.3. So the information on which page each of these words appeared in the document is retained. And so if we look at the last part of this data frame, the tail, right, 42, there are 42 pages. There were 42 pages of text that I started with, right? And so that information is retained in this resulting data frame. So if you wanted to do some kind of statistics on the words and you wanted to do a page count, for example, for whatever reason, that information is available to you in this outputted object. for what I'm doing, I'm not terribly interested on what pages these words occurred. And the nice thing about this tidytext output is that now that things are in a data frame, I can operate in the dplyr world, sort of my preferred data manipulation world. And I can make my word counts data frame by just doing a grouped summary. So group by word, and then summarize count equals n. And so whatever words appear multiple times, this whole step here is just going to count up the occurrences of each word. Last thing I'll do is I'm going to arrange in descending order so I can see the most frequently used words in Justice Neil Gorsuch's majority opinion for this particular court case. And we'll check that out. And there's the word the, of, and to. So there's a bunch of stop words in here, and we'll get to that in the next step. We can remove these pretty efficiently using the tidytext package as well. But for now, I just want you to see that once we got down to this tokenized data frame, then we had a nice data frame object that we could do operations on using the dplyr methods that I'm really familiar with and that I like a lot. Here's a little post-recording follow-up for you guys. I watched that last section of video and I realized that I said that we were done with the single opinion case, and I said that we walked through how to get the case text and then parse the case text, and get the markers. But I didn't really button it up for you guys very tightly, so I'm going to do that now. So let's take out, no, that's not where I want to put that. So down here in the console, I'm going to clear everything out. Okay, rm list equals ls. Okay, clear it, make everything nice and clean, and just go through this for the single opinion case. So let's set case. Let's do this first. Slip 2019 189526. Okay, so that's our text. That's our PDF. That's our Supreme Court case. That's all the text in that case. Okay, let's do the libraries. Let's do my search dictionaries. Okay, and this time I'm going to actually use the functions that I wrote. So get markers function. Okay, get markers ends there. Okay, so now I have the get markers function. Let's use the get markers function. Just a temporary data frame here. Get markers case equals case. Okay, so I'm calling to get markers. Now I have this temporary data frame that has my markers. Okay. Now I have a get case text. So I'm going to use that function. That function is going to get called within the filter case text function. Filter case text calls to get case text to get the text, and then it filters that text. So text, right, is going to be filter case text. The case is going to be case, and the page range is going to come from the output of get markers. And we were going through this for the majority opinion for this case from Justice Neil Gorsuch, so let's take that third row of the temp data frame, temp $start 3 to temp end 3. So that's going to be the text. And let's have a look. Text, character vector 1 to 42, so the 42 pages. Take a look at the first one. So we did get markers, and we got the markers. We did filter case text, and we got the filtered text filtered by the page numbers on which that majority opinion lives. Now we will tokenize the case text. So I need to execute that section so that tokenized case text is now a function that I have access to. And let's say, sure, let's just stick with text and call to tokenize case text. And the case text is text. We're feeding it that 42 element character vector. And now, okay, text is the data frame that we would like. Okay, so get markers, filter case text, tokenize case text, and we have the majority opinion, all the words of the majority opinion written by Justice Neil Gorsuch for this particular Supreme Court case.